we'll continue with the question we were solving yesterday before we go into something else. So we are going to continue with the question we were solving yesterday before we go into something else. Let me check for the questions. What was the last question we solved yesterday? You said what? Look at this question. Read the question, please. Okay, no problem. Now look at the issue of the following. Next question on measurement and units. We still have other questions, and we are still going to go further today. Which of the following? Each of the options below. Each of the options below. Each of the options below consists of a physical quantity. Each of the options below consists of a physical quantity. Each of the options below consists of a physical quantity and its corresponding units. 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 Except A, acceleration meter per second square, B, force kilogram meter per second square, C, momentum Newton seconds, D, potential energy Newton meter, and E, power joule per second. What's the question again? Which of the words each of the options below, that's each options below, consists of a physical quantity. Now, what are physical quantity? We have fundamental quantity and derived quantity, right? We have fundamental quantity: length, mass, time, temperature, current, amount of substance, and luminous intensity. They are fundamental quantity. You have 7. And derived quantity can be area, volume, velocity, acceleration, speed, density, and the likes. It was now asked that which of the following, each of the options below consists of a physical quantity and its corresponding unit, the unit of that quantity. Now, look at it now. Let's look at the corresponding unit. Is this thing correct? They now say except. So we are going to point out the one that is not correct. We are going to point out the one that is not what? Okay, let's check it out. What's the unit of acceleration? Derived unit of acceleration, meter per second square. What's the derived unit of force? Kilogram meter per second square. But the SI unit of force is what? Newtons. But the derived unit of force is what? Kilogram. Kilogram mass times acceleration, right? Acceleration is what? Meter per second square. So that's mass times acceleration, that's kilogram meter per second square. Momentum is what? What formula for momentum first? You have to ask yourself, what's that formula for momentum? Momentum is the product of mass and its velocity. Product of mass of a body and its velocity. The product of what? Momentum is product of mass of a body and its what? Velocity. How would I say momentum? Product of what? Product means multiplication of mass of a body and its what? Velocity. So now from this derived units, what's the unit of velocity? Meter per second. What's the unit of mass? Kilogram. So what's the unit of momentum now? Kilogram meter per second. Now, and here I can't see kilogram meter per second. So which means which is wrong. The one that is wrong is the what? Answer. They said which of the following quantities consist of its units and the quantity, except so this one, potential energy, Newton meter. I told you that energy, work done, energy is converted to work done, and the formula for work done is force times distance, Newton and what? Meter. Am I communicating now? So this can also be what? Energy. Am I communicating now? So potential energy, when you talk about potential energy, That's what mgh. Is it the formula for potential energy? Mg is a formula for force. A force acting at a particular what height. A force under gravity. You know that what's formula for force? Exactly. Ma, right? A is an acceleration in a linear motion when the motion does not involve a particular height. But G is an acceleration that is what? That involve a what? Particular what? Height. Acceleration due to what? Gravitational force. And divine weight for you yesterday, and this is what? Mg force. This is also acceleration. But the acceleration here is acceleration due to what? A particular what? Height. Acceleration due to gravity. What's the unit of G yesterday? Meter per second square. What's the unit of A? Meter per second square. What's the unit of height? Meter. This is also what? Newton meter. So this is very, very what? Correct. That's Newton times what? Meter. Am I too fast? I'm okay, right? Now, out of power, because we have a lot to cover. What's the formula for power? Power is what? That's work done over time. Thank you very much. Now, work done over time. That work done over time. So now, work done is what? Joule. The essence of work done is joule. Time is what? Second. That's joule per second. So now, this is what? Wrong. Isn't it? So now, next question. Next question. Next question. Which of the following units? 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 Which of the following units is equivalent to the watts? Which of the following units is equivalent to the watts? Which of the following units? Which of the following units is equivalent to the watts? Which of the following units is equivalent to the watts? What's the unit of? You ask yourself, what's the unit? Where is watt getting from? What's the unit of watts? I mean, watt is a unit of what quantity? Power. Good of you. All that you are doing well. Thank you very much. Joule per second is also a unit of power. But the one that is accepted by international scientists, SI unit is what? Watts. So good. So now, therefore, we now say which of the following units is equivalent to the unit of watt. Option A was kilogram meter per second square. Option B is kilogram meter squared per second cube. Option C, kilogram meter squared per second squared. Option D, kilogram meter squared per seconds. Which of the following is equivalent to the watt? Watt. In that case, watt is a unit of power, right? I'll go and what's my thinking? What should be my thinking? My thinking is to go and bring out the formula for power. Formula for what? Power. And power is what? Work done over time. I will not use joule per second. I'll also bring out formula for work. These exam questions we are solving here. I'll also bring a formula for work. Work is what? Force times what? Distance. What's time? Time. And look at my unit here. I'm having kilogram. I'm having mass. So I will need formula for force. Formula for force is what? Mass times acceleration. I'll still break down the formula for what? Force again. Can you see? We are writing exam. Now, formula for force again is what? Mass times what? Acceleration times this distance. This is it over what? Time. So mass is what? Unit of mass is kilogram. Abbreviate it. Unit of acceleration is what? Meter per second squared. And unit of distance here is what? Meter. So now, meter and meter can multiply each other. So this will now go give me what? Kilogram. Meter times meter, that's what? Meter squared. Second per second squared. I'm having over time. Time here is what? Second. I'm going to apply law of VDC here. This is also the same thing as what? Kilogram, meter squared, second squared over seconds. I'm taking step by step so that everybody understands what I'm doing. So this now leads us to what? Kilogram, meter squared per second squared. This division will change to minus based on law of indices. And there is invisible one here. A is also the same thing as well. A is for 1. Put that one here. So minus 2 minus 1 minus 3. So now that's kilogram meter square per seconds cube. Kilogram meter square. That's why you have to solve a lot of questions before your exam. Because when you just see this in your exam, you don't have time to think. You have a lot of questions to attempt. So all this will take your time. So that's why you have to be exposed to all your past questions One question in CBT, I get him now. Different questions online, different test queues. I get him now. You go into different challenges so that you'll be very, very fast. So when you see question, it will not be new to you. So option B is the right answer. Next question. You are going to do this yourself. You do this yourself. Now, these 3 questions, the 4 questions I'm having here is to be done by students. Is to be done by students. And question 1, oh yeah, right. Which of the following physical quantities? Which of the following physical quantities can shift the chair forward very well, so that when you want to stretch your leg, it will not affect it? Which of the following physical quantities is correctly paired? Which of the following physical quantities? Basit. Let me check. Sorry, Mustafa, check. Which of the following physical quantities is correctly paired? Paired means when you combine things. I get it now. Paired with its corresponding SI units. Which of the following physical quantities? Which of the following physical quantities? Which of the following? Be careful. So you can adjust a little bit. Shift out. Put out your leg so that you'll be able to sit down very well. Oh yeah. So, which of the following physical quantities? And you can also shift that table and chair to that side so that you can stretch very well. Which of the following physical quantities is correctly paired? Is correctly paired? Is what? With its corresponding SI units. With its corresponding SI units. Option A. Let me write the option. With its corresponding SI units. With its corresponding SI units. Which of the following physical quantity is correctly paired? Is correctly paired with its corresponding SI units. With its corresponding SI units. With its corresponding SI units. Option A. Density. That's kilogram meter cube. That's how it is. So this is how it is exactly. Option B. Per joule per seconds. Option C. Specific latent heat. That's joule, kilogram per Kelvin. And option D. Pressure. Newton per meter. What's the answer, class? What's the answer? Song that B. Which of the following physical quantity is correctly paired with its corresponding SI units? Now, even though if you are a student that does not know the formula for specific latent heat, there is answer there. The one that is correctly paired. So it means out of 4, 3 is not correct. It's only one that's correctly paired with its units. That the quantity and the unit are both correct. When you check this density, is the unit of this density correct? What unit of density? Kilogram per what? Do you see the power there? What of power? Power can be joule per second. Down. So which means this is well correct. You go to the next question straight away. You don't waste your time. It's an objective question. I get me now. So which means this is not correct. Even though if you have never had a specific latent heat before, it's not correct. Why do you have seen one that is correct? You pick it and go to the next question. Pressure is not correct. What is the unit of pressure? Unit per meter square. I get me. You have other units also. So which is what? Option B is the right one. So next question. Next question. So you have to be very, very smart. Which of the following physical quantities are derived? 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 Roman figure 1, area. Roman figure 2, trust, Roman figure 3, pressure, Roman figure 4, mass. Option A, Roman figure 1, Roman figure 2, Roman figure 3, Roman figure 4. Roman figure 1, Roman figure 2, Roman figure 3 only. Option C, Roman figure 1, Roman figure 2, Roman figure 4 only. Option D, Roman figure 1, Roman figure 3. Look at the question. What's the question? Which of the following physical quantities are derived? Which of the following physical quantities are derived? Now, this area is derived, pressure is derived, thrust is derived. Do you know that thrust is a force, right? Thrust is derived, area is derived, pressure is derived. But mass is not what? A derived quantity. Mass is a fundamental quantity. We have some fundamental quantity. Anyone you didn't see there, you know, when you are being taught, you didn't see this under fundamental quantities. It means they are derived quantities. You have to be very smart. This is the only one you see under fundamental quantity. So this is the fundamental quantity, which means Roman figure 1, 2, 3 are what? Derived quantity. Even though you don't know the meaning of thrust, thrust is a force. I get him now. It's a force that pulls out smokes in aircraft. I get him now. It's given by thrust, is given by mv. So even though you don't know the meaning of thrust, you were never told a thrust is a fundamental quantity. So 1, 2, 3 is the right answer. Option A. So your exam is about smartness, not knowing alone. Smartness. 1, 2, 3. 1, 2, 3 is the derived quantity. Sorry, I thought this is 1, 2, 3 alone. That's option what? Option B. Am I getting now? Option B. What's the next question? Which of the following quantities has the same units? Which of the following physical quantities has the same units? Which of the following physical quantities? Which of the following physical quantities? Which of the following physical quantities has the same units? Has the same units as that of products of mass and acceleration? Which of the following physical quantities has the same units? Has the same units as that of products of mass and acceleration? What's product of mass and acceleration? That's force. So which means which of the following physical quantities has the same unit as force? So you have to be very smart, please. What's the answer here? What's the answer? Option B, right? Now, last question, so you can go to the measurements in venial caliper. Last question. In which of the following physical quantities? Can you see? The exam is very simple. In which of the following physical quantities? You know what they call physical quantities? Fundamental quantity, derived quantity. In which of the following physical quantities is the SI units? Is the SI unit not correctly indicated? In which of the following physical quantities is the SI unit not correctly indicated? In which of the following physical quantities is the SI unit not correctly indicated? In which of the following physical quantities is the SI unit not correctly indicated? Option A, you do it yourself. Please don't pick the answer unless I say you should tell me the answer. Just go and pick your answer, know your answer, your book. I get you now, write it down, but don't say it loud. I want everybody to think for this last question here. What's the question again? In which of the following physical quantities is the SI unit not what? Correctly indicated? So now, torque, Newton meter, and please don't say the answer. Pick the answer in your book. Impulse, Newton per seconds. Option C, acceleration, meter per second square. Option D, momentum, Newton seconds. Ṣé náà wà? Ọ̀hún tí mo náà dé àbí? Tàbí màá lọ waste epo ni. Please, all what we have been taught by Mr. Gideon today, go to your textbooks. Go to your textbooks. If you want the PDF can be sent to you also. Go through your textbooks. I get him now, but it's good to work with hard copy. Everything is there. Test for chlorine and so many things. Everything is there. Go to your textbooks, your wave, go to your textbooks, your biology, ecology, go to your textbooks. So your 4 textbooks should be with you. It's very important. So now, where am I? Now, what's the right answer here? Momentum. Impulse. Momentum. Somebody pick impulse, somebody pick momentum. Let's hear the question. Torque is the moment of a couple. Moment of a couple is force times perpendicular distance. Force times distance between two couple, between the two forces. This is correct. A is correct. The quantity and the unit is correct. Acceleration is unit of acceleration in meter per second square. C is correct. So this is now our answer. Our answer will be between B and D. So our 50-50 will be between B and D. When we talk of impulse, what is formula for impulse? Impulse is force times time. And the unit of this is Newton seconds. Which means this option is not correct. This option is not correct. Now, what is the formula for momentum? Momentum is what? Mass times what? Velocity. Now, and in our option, what is not the units? That's kilogram, meter per seconds. Now, but in our option, we saw Newton seconds. So, which means the two. Now, don't let us to. My very sure option B is very wrong, isn't it? Let's try if we can generate these units. Let's try and use our sense. Now, velocity formula. Acceleration, inside acceleration, I can see velocity. Acceleration formula is what? Velocity over time. What if we make this velocity the change of solid formula to become option B is the accurate answer here. Based on this is the first option that has wrong unit. When you see 2 options that are correct, you pick the first one. But let's see what verify. Let's cross multiply. Acceleration times time equals what? Velocity. That's now what? What's the unit of that? Now, let me now bring what's the unit of acceleration here? That's meter per second squared times time per seconds, right? Velocity. So therefore, if I'm having my velocity here can be replaced with this unit. Am I calculating now? I can write my M, mass times velocity. Hope you are clear. What unit of mass? Kilogram. I can try to represent this my velocity My velocity is what? Meter per second square per times seconds, which is meter per seconds, right? At the end. Now, if I put meter per seconds here, I will not still get Newton seconds. I will still get Newton seconds. I can get it. I will get it. Look up. Don't let us work out the mathematics. Don't let us what? Let's just bring the unit like that. Meter per second square times what? Seconds. Mass times acceleration. Mass times acceleration is what? Force. So this is mass, this is acceleration, this is what? Time. I get you now? So now, when we now check, mass times acceleration is what? Force times time. I get you now? Do you know that momentum is also equivalent to, can also be equivalent to unit of impulse also? Impulse is what? Force times time, right? I will show you, I will prove it out for you. Now, so momentum, that force is what? Newton. Time is what? Seconds. We have to arrive at Newton seconds as the unit of momentum. Can you see I arrive at Newton seconds as the unit of momentum? I brought this here like this. But I didn't bother to compute. Well, if I compute, I'll be getting meter per second. I just leave it like that. I brought it here. And this is which is for velocity. Now, and this is mass, kilogram. So I now say kilogram times this. That's mass times acceleration, which is force. And this my seconds is time. Force times time. Force, the SI unit of force is Newton. Newton times Newton seconds. And import, what is from the second equation, from the what was it called? The Newton second law of motion. Who can define Newton's second law of motion? So today I want to show you that momentum units can also be impulse units. But the normal momentum unit is kilogram meter per second, isn't it? Because momentum is what? Mass times velocity. What's formula for momentum?
Mass times velocity.
What's formula for momentum, class?
Mass times.
Class, what's formula for momentum? What's mass? What's unit of mass? Kilogram. What's unit of velocity? So what's now the unit of momentum? Kilogram meter per second square. I told you for you yesterday, I told you you have to study it, right? Unit of momentum is kilogram meter per what? Per second. Kilogram meter per second. Yes. Now, it has stopped. Okay. Now, look at it now. Where am I? But momentum can also be what? Newton seconds. Who can state the Newton second law of motion for me? No, that's Newton first law of motion. Who can state Newton first a second law of motion for me? Okay. Yes, place it out as you understand. Be fast. We don't have time. That's Newton's third law of motion. Not inversely. Oh yeah, class. Newton's second law of motion says that the force applied to a body. Are you getting me now? The force applied to a body is directly proportional to the rate of change of momentum. When you say rate of change of momentum, rate of change of momentum, rate of change, there will be time. That rate there is showing the time. Are you getting me now? Is directly proportional to the rate of change of momentum, which takes place in the direction of what? Force. The force acting on the body is directly proportional to the rate of change of what? Momentum. When I say change of momentum, change of movements. I get him now with particular time and takes place in the direction of what? Takes place in the direction of the force applied. I get him now and takes place in the direction of the force applied. So now, which means as this is a direct relationship. This is a what? If you are applying the force on the body, as this force is increasing, the momentum also will be what? Increasing. What's the meaning of momentum? In simple man language, momentum is what? Movement. Can I drag him? Can I drag him? But I can drag him. No, I can drag him. But the force I'm applying is not enough. If I apply a greater force, his own movement will increase. Greater force, his movement will increase. The more force I apply, the more he also run. So he can be running after me if I'm applying more greater force. So the higher the force, the higher his speed also. And it's taking place in the direction of the force, of the force which I apply in my direction. So the rate of change, the force acting on the body is directly proportional to the what? Rate of change of what? Momentum. I get it now. Rate of change of what? Momentum. We use this symbol to represent momentum. I get him now. So therefore, let me change this P to let me change it. Let me change this to momentum formula is what? Mass times what? Velocity. F that proportional to what? Change in what? mv over t. When they say change in mass times velocity, change in velocity. Mass is constant. Mass doesn't change. The mass of that body does not change, but its velocity can change. The mass of this body cannot change, but the velocity can what? Now, because mass is what? Constant. Now, look at it now. When I say change in velocity, the velocity at initial position is represented by u. I get it now. What is the velocity at initial position? Is what? 0. Now, if we acquire a motion, the velocity you'll be moving with is what? Called final velocity. So, possibly if you have a value, it's going to have a what? A value. So, therefore, I can now change this into force, then directly proportional, force, directly proportional, force, directly proportional. This is what? Mass is constant. I'll just say it is only velocity that can change. The mass cannot change. This means this triangle here means what? Change. This triangle here means what? Change. You can stand up if you are tired of sitting. This triangle here means what? Change. Over what? Time. So F equals to what? M V minus U over what? Time. You can only remember Newton's first law and third law because of you can think of the application. But I've applied the application of Newton's second law now. I've done it for you now. So once you remember I was dragging him, the higher the force I'm applying to drag him, the higher the greater is what? Is movement also. The greater is what? Momentum. Momentum is what? Movement. So if my force is, this means direct relationship. If this one is becoming higher, this also will be becoming what? Higher. And as it's moving, the time is also what? Increasing. Am I communicating now? Am I communicating now? So now, yeah, look up now. Where am I? There's something I want to bring out. If I cross multiply, I can cross multiply. I can cross multiply. Field house, that was force times time equals to m v minus u. Now, what's formula for impulse? Force times time. I get him now. So unit of impulse is what? Now, this is momentum, right? Mass times velocity, right? This can be a value or it can be 0. It can be 30. 30 minus 0 is what? 30, right? That which is the speed, right? The velocity times mass. That's the momentum, right? So I can represent this with what? Momentum. Momentum. I get it now. Equals what? Force times time. And your force is what? Newton. Your time is what? Seconds. That's why momentum can also be what? Newton seconds. That's why momentum can also be what? And even your impulse is Newton seconds. So impulse can also be kilogram meter per second. Why? Your impulse, this is Ft. Ft equals to m v minus u. Your impulse can also be what? Kilogram meter per second. Impulse, I can represent my impulse with what? Ft. Ft can be represented by what? I, right? Impulse. Impulse, or let me write it in full. Impulse, this is what? Kilogram. Velocity value will be what? Meter per what? Second. So you can see question like that. The unit of impulse, you will not see Newton seconds sometimes. You might see kilogram meter per second. Because equal to means what I'm having here is also equivalent to what I'm having here. That's the meaning of equal to mathematically. So which means this unit is very, very correct. So the one that is not correct here is what? Impulse. Can you say exam? Not that you were not taught, but we need to make a research. The one that is giving you difficulty, even though you get the answer mistakenly or by default you got the answer, but you don't understand, move closer to your teacher. Please, I don't understand this. There is one student that always do that. You get the answer, you just speak it by default, but you still move closer to me that why is this thing like this? So what? Because now I explain why this is the right answer. So when you get to your exam, you know why you are picking your answer. You not just be guessing and guessing and guessing. So now next part. Yesterday I showed you the diagram of vernier caliper. My charger. I showed you the diagram of vernier caliper. Take my charger from that bag there. I showed you the diagram of vernier caliper yesterday. So we are going to calculate. We are going to make some calculation of vernier caliper. We are going to just go and plug it. Just go and plug it. Remove the pin. We are going to calculate what? We are going to use vernier caliper to measure length today. What kind of length does vernier caliper measures? Diameter, internal and external diameter of an object, right? Is diameter a length or not a length? Now, why is it a length? Who can divide diameter for me? It's a line that passes through center of circle and divides circle into two. So diameter is a line, so it's a length. So measurement of length, what are the apparatus used in measuring length? Meter rule, vernier caliper, micrometer, screw gauge. What are the things that look like meter rule? Steel tape that is used to measure length of a field. The longer meter rule can only measure 100 centimeter length. Are you getting me now? Now, where are we? So therefore, this vernier caliper is very clear to you. Where is the main scale? Where is the vernier scale? You can see it is well labeled. Clear? I get you now. This is the scale on this vernier caliper. And this scale is called what? Main scale. And this movable scale, I can move it. I will place the object I want to measure diameter here. If the object is of this size, I will shift this. What looks like a gun arm, I will shift it until it fits. So it's movable. This jowl here is what? Is a movable jowl. This true jowl is called lower jowl. So now this scale on this movable jowl is called vernier scale. It's called what? Vernier scale. Good of you. Now, we are going to answer so many questions on how to measure it. I have so many questions on the measurements. 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 Is this thing bold enough, or I should increase the bolded? I should increase it, right? What of this way? What of this way? Can you see from far? Can you see this now? If you can't see it, I can bring out another question. I have a better diagram that is more bigger than this. Please, sincerely speaking, can you see it? You can see it, right? Okay then. Now look up now. This is what? Main scale. This is what? Vernier scale. This scale here is vernier scale. And the scale here is what? At the upper part is main scale. Main scale, can you see? Vernier scale. What's the value you can see here? I can see 5 centimeter. I can see 6 centimeter. How many lines can you count within them? 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means this is 5 centimeter. Do you know that in mathematics we have some numbers between, decimal numbers between 5 and 6. How can I derive some decimal numbers between 5 and 6? Decimal number are number that has what? Points, right? Example of decimal numbers. 3.4. This is a decimal number because it has what? Points between these two digits. So now what are the decimal number between 5 and 6? 5, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, Ifemi, 5.8, 5.9, then I'm having what? 6. These are the what? Favor. Decimal numbers, we have more than that. I get him now. We have more than that, but in short form, we have more than that. You know, you can say 5.01, but we are not doing that. We have in a short form. Now, look at it now. Here, this is 5. Everything now. We don't study today's class now. If you are not here today, we are done with our previous class, with our question. We ended our previous class with questions, so the question finish it up. Now, we are starting today's class. So if you are a new physics student today, I have told that vernier caliper is used to measure diameter of what? Of a circular object. Now, and I'm teaching you how to use it, how to measure, how to read the scale. So we are reading it, how to read those scales. These are called scales. I get you now. So now, this is 5. Now it means you can see some lines between 5 and 6. Those are the decimal numbers. 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, and what? 6. Now, what kind of scale is this class? Main scale. What of this scale? Vernier scale. What do you see here? 0. You first check the values. This is what? 5. It means what are the numbers between 0 and 5? That's 0, this is 0, 1, 2, 3, 4, 5. Now, which means this will be 6, 7, 8, 9. And this is what? 10. Good. Good. So therefore, what is the reading accuracy of meter rule? 0.1 centimeter. If it is centimeter, reading accuracy. So I'll use capital letter A. For meter rule is what? 0.1 centimeter. What of millimeter? For vernier caliper, so the reading accuracy 0.01, we are increasing by 0, right? Centimeter or what? Millimeter. So for micrometer screw gauge, if you are here just now, don't write. If you are writing micrometer screw gauge, you are not helping yourself if you are writing when I'm explaining. Please listen attentively. Everything is in your textbooks. Everybody have materials. I get it now. Please don't write now. Micrometer screw gauge. What is the reading accuracy of micrometer screw gauge? I use this. This is how I studied mine. You increase the 0 to the increase it by 0.001 centimeter. Increase this value by 0 or 0.01 millimeter. Okay. Now, what are we trying? We are reading the scale of vernier caliper, right? Now, look up now. I will now tell you the techniques. You have known how to read values between those lines. You have known how to read values. That's what we have done now. I have taught you how to recognize. I have taught you how to recognize vernier scale and what? I have taught you how to recognize what? Main scale and vernier scale. Vernier scale and main scale. So now the next thing is to learn how to read those scales. Am I communicating now? You have learned how to identify each numbers. You have learned how to identify each numbers. The next, how to read each scale, scales, and how to merge it together to form your readings. Now, for micrometer scale and for vernier caliper, we are going to be using this formula: actual reading actual reading equals what? Capital letter M, which is main scale reading, plus what? Vernier scale reading, times what? Reading accuracy. Actual main scale reading, M here is representing what? Main scale what? Reading. That's what? Capital letter M. V is what? Vernier what? Scale what? Reading. Which is what? Capital letter V. And A is what? Accuracy. Reading accuracy. Which capital letter what? A. The reading accuracy. Am I communicating now? Good. So, this formula is used for vernier caliper and micrometer screw gauge. Let's now go through main scale reading. When you see the last line you see before the vernier scale, that is where you are going to stop. The last line you see before the this is how to read your main scale reading. The last line you see before you see your what? Vernier scale. This is vernier scale. This is main scale. The last line you see before you see your vernier scale is where you are going to what? Stop. I'm having 5 centimeter here. What is this? 5.1 centimeter. What is this next line here? After this line, you can see any other line, they are within this vernier scale. So I have to stop. I will write what? 5.2 centimeter. So therefore, my main scale reading, which is my capital letter M, is what? 5.2 centimeter. What of my vernier scale? So I'm done with my main scale reading. Class, I'm what? So we need to check the what? Vernier scale reading. What is the value between here and here? 1, 2, 3, 4, 5. This one is read in old number. Use old number. I get him now. They are old numbers for vernier scale reading. So therefore, this is 0. This line is 0 for vernier scale. 1. And favor. 2, 3, 4. I'm not just counting. I will look at the where the lines coincide. What's the meaning of coincide? Where the lines meet, where the lines intersect. Okay, let's check a line where the lines of vernier scale coincide with what? Main scale. Yeah, class. So yeah, check where does the line of vernier scale coincide with the line of main scale. Class, check it yourself. After 5, we have 6. Somebody says 6. That 0.6 on vernier scale. That 0.6 on vernier scale. That line coincides with a line on main scale, right? 0.6 on vernier scale. Good. Any other answer? You are free. Is a free word. You might be seeing something. The way we see it is different. Any other answer? Everybody all agree that line 6 on vernier scale coincide with a line on main scale, right? Okay. So my vernier scale reading is what? I will call it 6th division. Say 6th division. That is the 6th line. The 6th line. We call it so 6th line, the 6th division. Now, okay. What of now? Where can I get my A from? I know it. What is this unit? This unit is in centimeter or millimeter? Is it in centimeter or millimeter? Which value of the reading accuracy will I be working with? Is it centimeter or millimeter? I'll be working with centimeter, right? What's my A here? Oh, this is micrometer screw gauge. We are on vernier caliper. That's what? 0. What? 0.01 centimeter. Okay. Now, M plus VA is your formula. Let's now go on now. What now the actual reading on this scale now? Nifemi, stand up. Stand up. What's the actual reading on this scale? How can I compute my value? Nifemi. How can I compute my value? Have your seat there. Have your seat. Nifemi, how can I compute my value? Enter. Sit down. Nifemi, how can I compute my value? I know my M, I know my V, I know my A. I'm looking for actual reading and you are given a formula. You know everything you needed to get the actual reading. Nifemi, what will I do with this formula? I know my M, I know my V, I know my A. Nifemi, what will I do to get the actual reading on my vernier caliper? What will I do, Nifemi? What's the step to take now? M value, you are going to substitute. Say substitute. You are going to what? Wherever you see M here, you are going to put. Another word for substitute is represent. Replace. You are going to replace with 5.2. Wherever you see V, you replace with what? 6. Wherever you see, you replace with what? 0.01. What is the mathematical relationship between V and A here? When I say mathematical relationship, the operator that is there, is it multiplication, addition, subtraction, or what? Division. What can you see between V and A here? It might not be everything, but what is the mathematical relationship between V and A? Multiplication. So therefore, the value I'm putting here and the value I'm putting here will be multiplied together, right? So therefore, your actual reading, M plus VA. Your M is what? Your main scale reading 5.2. V is what? What of V? 6 times 0.01. That's the reading accuracy in centimeter for vernier caliper. That's 5.2. 6 times 0.01. 0.06. That's 5.2 plus 0.06. 5.2 plus 0.06. 5.2. 0.06. 0. What any other number you will be arranged under numbers that come after point. 0.6. But number before point will be arranged under number before point. Listen attentively. So now there is invisible 0 here. And if there is nothing here which is 0. 0 plus 6 is what? Say 6. Monyoluwa 2 plus 0 is what? 2. The point must be arranged on a straight line. That's 5. So that's what? 5.26 centimeter. 5.26 centimeter is our final answer. If you are a type, you can just say 0.01 times 6 straight away and add it with this without writing formula. You can just do this in your brain when you are writing objective questions. I get me now. That's our answer. 5.26 centimeter. 5.26 centimeter. Please, if you have a question, don't hesitate to ask. Ask me a question from what I've explained to you. Now, this unit you see on the scale here will determine the reading accuracy you are going to use. If you see millimeter here, if it is 5 millimeter, 6 millimeter, they write here. So your reading accuracy will not be 0.01 centimeter. Your reading accuracy will be what? 0.1 millimeter. That's what you're asking, right? So the unit you see here will determine the reading accuracy I'm going to pick out of my reading accuracy for vernier caliper or micrometer screw gauge. Right? Now you can now write. You have received it. Then you cannot document it. But listening is by receiving. But when you don't receive and you are documenting, documentation will go. It can be stolen. Anything can happen to it. This is the question. This is is just to read this. This is the question. When you see this, you know that is main scale, venial scale for venial caliper. This is the question. It has stopped. Eh? This is the question. You can pause it while writing. You can pause it while writing.